So what if I told you that one of the most revolutionary communication technologies in all of human history wasn't born in some high-tech lab, but from a moment of just profound personal tragedy? Well, today we're going to uncover the absolutely heartbreaking story behind a language that conquered distance, Morse code. You hear that? That's not just some random pattern of sounds. For over a century, that was the sound of information traveling faster than any human, any ship, or any horse ever could. It's the language that literally shrunk the globe, and trust me, its origin story is one you are not going to forget. To really get the impact of this invention, we need to rewind the clock a bit. See, before the 1830s, our world was, well, it was a much, much bigger place. And why? Because information was stuck in the slow lane. It could only travel as fast as a horse could run or a ship could sail. I mean, really think about it. You have an urgent life or death message. It's handwritten, handed to a writer, and sent off with little more than a prayer. It could take weeks, maybe even months to arrive. That is, if it arrived at all. This incredible, agonizing delay was just a fact of life. But for one man, this system wasn't just slow. It was about to become the source of an unbearable tragedy. So, who was it that finally solved this massive problem? You might think an engineer or a physicist, right? Nope. It was an artist. And his mission was sparked by a piece of devastating news that arrived tragically, painfully late. Let's meet Samuel Morse. Now, on the surface, he was a respected art professor at New York University. He was a painter. But underneath that artist's smock, he had this deep fascination with science, especially with that new, kind of mysterious force everyone was talking about, electricity. The year is 1825. Morse is in Washington, D.C. working on a painting when a letter arrives by horseback from his father. His wife, she's gravely ill. He immediately prepares to leave. But then, another letter comes. She's gone. He raced home for days, but by the time he finally arrived, she had already been buried. He never even got to say goodbye. Can you imagine? That grief, that fury, it became this incredibly powerful catalyst. He was heartbroken, of course, but he was also furious with a system that let such critical news travel so slowly. His quest wasn't for fame or fortune. It was a deeply personal mission, fueled by tragedy, to make sure no one else would ever have to suffer that same agonizing delay. So fueled by this mission, Morse essentially turned his attention from paintbrushes to wires and magnets. He became determined to harness the power of electricity to send messages at, quite literally, the speed of light. And his creation? The telegraph. The concept itself was revolutionary, but also so elegantly simple. A system that could send electrical signals down a wire, closing these vast distances in just an instant. Okay, so how did this thing actually work? It was really a clever mechanical process. An operator would press a key, which completed an electrical circuit, sending a little pulse of electricity down a wire. Then, at the other end, that pulse would activate an electromagnet, which moved a small marker to make an indent on a rolling strip of paper. It was a physical, tangible way of capturing an invisible electrical signal. And in 1837, inside a university classroom of all places, Morse gave the first public demonstration. He successfully sent a message across a wire, proving to a completely stunned audience that his idea wasn't just a theory, it actually worked. Instant long-distance communication was now possible. But there was a huge problem. Okay, the machine could send electrical pulses. Great. But how do you turn those pulses into words and sentences and ideas? Morse had the hardware, but he desperately needed the software. He needed a language for the machine to speak. This is where a brilliant young man named Alfred Vail enters the story. He saw Morse's demonstration, was totally inspired, and offered his help and his resources. It was Vail who really refined the system, developing that simple key and sounder we think of today. And, crucially, he helped pioneer the idea of using a code made of embossed dots and dashes. So, let's just put ourselves in their shoes for a second. The challenge was immense. How do you translate the entire English alphabet, with all its complexity, into just two simple symbols? A short pulse and a long one, a dot and a dash. I mean, where would you even begin? Their solution was absolutely brilliant. Why? Because it was based on efficiency and data. Instead of just assigning codes randomly, they decided to analyze the English language itself to see which letters were used the most often. Their method was basically pure data science, just 19th century style. They poured through newspapers and literally counted the frequency of every single letter. They discovered that E was by far the most common. So they gave E the simplest, fastest code possible, a single dot. And the least common letters, like Z, they got the longest, most complex codes. It was just an elegant system engineered for pure speed. Now, you'd think that in our world of smartphones and satellites, a 19th century code would just be a museum piece, right? But you know what? You'd be totally wrong. In fact, Morse code is still, surprisingly and vitally, alive today. Think about that for a second. Over 180 years later, a refined version called International Morse Code is still actively being used. In our world of constant technological disruption, this beautifully simple system just endures. So where do we even find it? Well, pilots use it to identify navigational beacons. Naval ships use it for signaling when radio silence is absolutely critical. And of course, it remains the universal language for emergency distress signals. Its simplicity is its greatest strength. It works when other, more complex systems might fail. And this is perhaps the most powerful example of its enduring genius. The code is so fundamentally simple that it can be adapted for assistive technology. People with severe physical disabilities can use it to communicate, sometimes by doing something as subtle as fluttering their eyelashes for a dot and closing their eyes for a dash. It's just a stunning testament to a design that is fundamentally and beautifully human. So we end right where we began, with this simple pattern of sounds. In our age of constant, instant information, what can we learn from a code born from tragedy and built on just two sounds? Perhaps it's a reminder that the most powerful innovations aren't always the most complex. Sometimes they're the ones that solve a fundamental human need with elegant, timeless simplicity.